to our 97th Science Cafe. And I didn't pick it with me. We've got a 100 that's coming up in September. And if you haven't been here before, then we welcome you to it. My name's Paul Adams. I'm Dean of College Education, and also one of two people, Cheryl Shepard Adams, around here somewhere, that brought the Science Cafe today when we started back in 2008. So we thank you for being here. In case you are new, remember, part of this is a chance to find out something new or exciting about the world that maybe you haven't. Chance to interact with an expertise and ask your questions. So discussion is a very good part of it. Well, tonight we're fortunate all the way from Italy, our 4 days, whichever way you want to look at it now. Dr. Nicholas Caporuso. I think I got it right.
Perfect.
Right. He's an assistant professor in the Department of Informatics, and web development, web management information is his main area. But tonight he's going to be talking about AI, and I guess AI, I should get the whole title. But anyway, artificial intelligence, which if you've listened anywhere, is everything. And that's it. So let's give him applause here and welcome him up. Here you go.
Thank you. Thanks for being here tonight. It's great to see such an amazing crowd. Just one rule for tonight. Feel free to interrupt me whenever you want with questions. I'll be happy to answer to any comments. This is just to get familiar with artificial intelligence, which is still developing. So some of your questions might not get an answer tonight, but we'll get an answer in the near future. But first of all, I have a question for you. What is this? Any idea? Yes?
Eyes.
What?
What?
Eyes? Yes. Some of it is eyes, is faces. What else?
Maybe some animals.
Animals. Great. So why is eyes, why are there faces, and why are there some animals all together? So what you're seeing is how an artificial intelligence system sees the world. We are getting into a representation of an AI brain. This is how AI sees our world. And one interesting thing is that, as you can see at the beginning, there's nothing. There's just lines. And then some patterns emerge, and then you can start seeing some eyes, some animals, dogs, faces, and other things. And tonight we're going to discover how AI works and how is it possible to achieve a representation of the brain and how AI sees the world. But I know why you're here. I mean, if you are a fan of Terminator, as I am, you're here because you want to know, when is Skynet going to happen? That's the very first question. And in fact, when I was preparing for the talk, I was meeting people and they were asking me, are you going to tell us when Skynet is going to happen? Of course I am. That's the purpose of this talk. But you're here for a second reason also. And that's it. You're afraid of losing your job because of AI at some point. Now, I'm going to answer those two questions right away so that we can keep it smooth and simple and easy for the rest of our talk. We don't have to worry about robots killing humans. So when is Skynet going to happen? Well, later than the predicted date. The movie says 2029. It's going to happen probably 2050 and 60. So some of us still have some time. When will you lose your job due to AI? Well, that's something that it's really happening. Of course, it depends on the job, but it's going to be sooner than you think. However, is AI the problem? Well, if you think about machines replacing humans, I mean, that always happened. It always happened, and we're seeing this today. Machines that are not so smart replacing humans, right? We are seeing this as well. So other people are going to be replaced, and this is happening since the Industrial Revolution. So something I just want to share with you, if you're afraid about losing your job due to AI, well, it's happening anyway. What helps us keep our job is, the level of training, the uniqueness of what we do. And we'll learn that throughout the presentation. One more system I'd like to share with you is not this hallucination back again, but this one. And this is how an Amazon factory is managed. And it shows how we can get products so fast and so cheap. So this is what happens in an Amazon warehouse. There are robots taking your orders and carts and moving in the factory. And I want you to count the humans in there. And robots are synchronizing, taking orders, moving them across the factory, exchanging things. And then at some point, they deliver an order to another system that will take care of them. I'm going to speed it up a little bit. And there's one human in a factory picking the orders and selecting them. And all these robots are behaving in an intelligent way, right? They're able to understand where items are. They're able to move them. And again, the factory is empty. There are only robots there. But anyway, we enjoy when we interact with Google and we ask Google questions such as, will artificial intelligence, and then Google is already answering our questions and our inner fears. And we enjoy when Google suggests us a better route when we want to go somewhere so that we can avoid traffic, we can avoid accidents or other problems. And of course, we enjoy when Amazon suggests us products based on items that other customers purchased. But now we start to wonder, is this artificial intelligence? Are machine thinking? Or is this just data that is summarized and processed and presented to us? So we might think that this is not intelligence, right? And then there's one more system that I'd like to show you, and it's this one. So this is an installation that it's established it's held in the Jewish Museum in Berlin. And it's a robot writing the Torah, the sacred book for the Jewish. And there's a rabbi handwriting it, and then there's a robot writing it. And of course, the book could be printed, but now the robot is simulating human handwriting and writing the whole scroll, which cannot be used for religious purposes, but still it's an installation showing the potential of machines in replicating human activity. So this is pretty sophisticated because a machine is able to design alphabet, design letters, and write a scroll. Is the machine able to understand what it's writing? What do you think? Clearly not. Would you define a machine like this intelligent? Probably not. Probably no. We're back to the... Sorry. So, of course, the first difference is between automation and intelligence. So automation involved program things, program machines, and software that just does what we tell them to do. Intelligence involves some kind of intelligent behavior. However, humans act as machines most of the time. Think about when we're driving. Are we being intelligent? We're just following the rules, right? We're not hitting, pedestrians. We're stopping at the traffic light when it's red. Are we intelligent? So the real question is not whether submarines can swim. right? Can submarines swim? So one of the theorists of computer science back in the days told that the question of whether a machine can think is not relevant at all. The real question is another one. Can you figure out what that question is? Decisions? How do humans make decisions then? Based on what? Past experience. So this means that the real question is, can machines learn? And that's what we'll answer tonight. If machines can learn, that's already scary enough, as we will see. So I'll talk about artificial intelligence, which is a broad set of algorithms and computer software that incorporates 3 items. Artificial intelligence in general, which overlaps with automation a little bit, and it's machines that behave with some kind of human-like intelligence. Then there's machine learning, machines that are able to learn. And finally, we'll talk about deep learning. And the movie that you saw at the beginning with that hallucination kind of dream, that's deep learning. To do that, I'm going to use a very simple robot, a stupid one. You know the Roomba robot, right? It cleans. How many of you have that in your houses? Oh, OK. So not so many. So how does the Roomba robot work? So it has 4 sensors. One that tells if the robot reaches any stair. So it's a cliff sensor. So that if the robot is about to fall, then the robot backs up. We have a bump sensor to detect when the robot hits a wall. There's a wall sensor to see if there's any obstacles around. And finally, there's an optical encoder. And the purpose of that sensor is calculating calculating the distance and the rotation of the robot over time, so that it can go back to the base and recharge, right? So how does the Roomba robot work? 4 simple instructions. If you are towards a cliff, well, back up, right? That's the immediate thing that the robot needs to do. If you hit a wall, rotate. Simple. If you see a wall, keep the distance. And then measure your orientation and distance so that you can travel back. Is this an intelligent robot? I don't know, but someone mounted lights on the Roomba robot and took a very long picture of all the paths that the robot did over a cleaning session. And this is what we get. Pretty interesting, but it's not what you would do when you clean your house, right? That's a nice swing, but why is this? Well, because humans learn to make their job more efficient, whereas robots just receive 4 instructions that are standard for every house. So the first thing that we want to do to talk about AI and specifically machine learning is to design a robot, a Roomba robot, that can learn. So imagine applying that robot to this house and to a room which is shaped in a different way. Well, for this room, the best pattern would be something like a line that would cover all the room. But then that's the same shape, the same path and pattern wouldn't be suitable for this room here, because you would encounter tables, couches, and walls shaped in a different way. And here is where machine learning intervenes, and where we can take the Roomba system, take the same sensors, and program them in just a different way. what we are going to do is use reinforcement learning, which is a technique for educating humans as well, and specifically young kids when they're learning a language. And we are going to apply that to the Roomba robot. Let's design a completely new set of rules. Now, the purpose of the game, the purpose of the robot is not to clean the room, but it's to play a game. And the game is structured as follows. Every time you take one step, which is new, so over a spot of the house, of the room that you didn't cover previously, you get 1 point. If you cover a step that you covered previously, you get 0.5 points. If you bounce on a wall or if you flip, you lose 2 points. And of course, please memorize your steps and what you did so that in the next step you can do better. And now we can design a game so that the objective of Roomba is not to clean the house, but to get the maximum points. So what would the system do? The first time, it would fall off a stair, it would bounce on walls, it would make all the possible mistakes. The second time, it will learn that probably hitting a wall doesn't turn out to be a good strategy because you're losing points. So it will start to avoid walls. And then at some point, it will start to realize that walking over a step that was covered previously results in a lower outcome, so that Roomba will start to try to increase their points. And finally, our Roomba would be able to play a Pac-Man-like game where the objective is to cover all the spots, avoiding obstacles and monsters over there. Now, the point is, how much time will Roomba require to learn how to play Pac-Man? Let's see it. I have another video that shows reinforcement learning in Pac-Man. So this is a software designed for solving this game. And this is the first episode. And our hero dies. But after 1,500 episodes, the character is able to win 25% of the games. And then it keeps learning what to do and what not to do. And eventually, after about 6,000 times, and after trial and error, it will be able to play the game and to win 95% of the times. And of course, it will learn that eating monsters is good when they are white, otherwise you have to avoid them. Why does it take so long to train a machine? 6,000 times, 6,000 repetitions. Why? Should it be faster? Well, it turns out that machines learn exactly as humans do. The reason why we are able to play Pac-Man faster, and the reason why it doesn't take us 6,000 games to learn how to play the game, is that we incorporate previous knowledge in this game. So we already know that we'd better avoid the monsters, we know the instructions of the game, and we know that these are walls and these balls have to be eaten. We know that because we've read the instructions or we played previous games, and so we have that kind of prior knowledge. Some people try to compare how machines do and humans do when we remove that knowledge. So this is a simple game, and of course, that's the character. These are bad guys, and the character can climb the stair, and he has to avoid these spikes and move up, probably, right? And even if we didn't play the game, we can realize that. But this is how the computer sees the world the first time. They don't know what spikes are, where they are. They don't know where a wall is, where a stair is. They don't know the representation of the world. So some researchers did this. They had humans play a game with complete information. Then they removed the semantics, and they replaced enemies with standard boxes and staircases with standard boxes and spikes also. And of course, the time for learning the game increased. And then they removed also the object location. And time increased even more, threefold, right? So the problem is not that computers are slow, it's just that they don't have a clear representation of the world. And they have to achieve that before they can play. But once they do it pretty well. Now, the next thing I'm going to show you is this. So we've seen how to manipulate Roomba, how to make it learn something. We've seen how machines can play Pac-Man, but machines can learn how to walk. And even though they were not designed to have legs and to walk with, as humans do, they can emulate a human behavior just by learning it. So this is a software-made robot that is learning how to walk. He only has 2 legs, some weight, and then a sensor that calculates the distance from the floor. And it's pretty funny to see, the different strategies that the robot tries to implement. And I'm going to have some more fun later on with some videos. But as you can see, Skynet is watching you, and it's listening to all your laughters. So at some point, when Skynet will take some revenge, you'll be the one to blame. But as you can see now, after 3,000 episodes, the robot starts some kind of galloping, some kind of walking, right? And we are starting to feel for it. We really want it to be able to walk. And there are many challenges there. One is, the terrain is not constant. It's not just flat. It's changing. And so the weight is balancing differently. And the only information that the robot gets is, the distance from the floor and then the weight. 5,000 times, the robot starts to make some distance, but still falling. And now he figured out a way, almost, in which they can accomplish the task. And they're not walking like humans. So maybe we should take some examples, and maybe I'll see you all walking like this and taking some lessons from artificial intelligence. But they're doing that, right? The nice thing about this is that we don't need to program the robot to tell them what to do, when to stop, when to take a step, when to balance their equilibrium. They can do that just by playing a game. Of course, we can take it one step further, and all of you, I believe, watched this video. This is Atlas, a humanoid robot from Boston Dynamics. Oops. So now the robot can walk in real environments, and when there is an obstacle or different terrains, the robot can cope with that, because it can take the information learned from a simulated environment and it can replicate it in a real environment. There you go. And this is after learning some steps using software and, of course, in real environments. But the nice thing is that once one robot learns how to walk, all the replicas are able to do so. And wouldn't it be amazing if, after I learn math, my kids can learn math by just transferring that kind of knowledge? I mean, mind-blowing. And this is why Skynet will eventually happen. I'm showing you a video, and again, you might have seen this video, but now I want you to focus on something. Not only how humans are treating bots and robots, but also what it takes for a robot to learn. And that's failure. The more they fail, the more they learn what not to do and how to cope with information that they didn't get. It's easy to walk when there are no obstacles, where there's no one pushing you. But what happens when other variables that were not designed in the system are included there? So this is how they train this robot, which is called Spot. And again, it's from Boston Dynamics. And it's fun to see them walk and crash. But this is what happens. So the robot is able to respond to a stimulus that couldn't be programmed. That kind of response couldn't be coded any way. They have to learn it as we learn it. And so what happens is the more information we provide artificial intelligence and machine learning systems with, the more they're able to cope with variation. And of course, sometimes, they fail. Again, some other failures. But here, they're being stimulated to learn how to prevent from falling, how to cope with being unbalanced, pushed. And this is how people at Boston Dynamics have fun. So the robot is not falling anymore after that they are tested, but they can encounter, some other difficulties. And, human-robot collaboration is sometimes tricky. But see this one. So 2 legs being pushed and nothing happens. And again, the robot is able to balance. And this is the standard routine for training these kinds of systems, providing them with all sorts of information that they can learn from and adjust and improve their score so that as the Roomba, they don't flip and they don't lose points. And this is it. I mean, trying to hold a package and being, stopped by people. And this is completely autonomous, based on just learning. Well, that was too much. Okay. So what is machine learning? It's a pattern discovery process where machines take information from the outside and they learn from examples. They learn from previous experience, but they look at specific things that we'll later on call features, so that they can even cope with missing information, right? And we don't have to program them. They learn from examples. They learn from features, relevant information. Now, Pac-Man was learning from monsters eating or intercepting the Pac-Man, walls, and the fact that Pac-Man couldn't go through walls, the fact that eating the balls, was giving Pac-Man points, and this is what we call patterns. Now, a very simple machine learning system detects spam. And you have spam alert or spam filters in your mailbox, though from time to time it's reassuring to know that you've received $6 billion in your bank account, or all these kind of offers that really are, frankly, on the very bad days are kind of a comfort. But after you get 3 or 4 or 5 of them, and after you reply to 3 and you get scammers back to you asking for your bank account information, then you realize that you see a pattern and you avoid the 4th one, hopefully, right? So that's exactly what a machine does. And we've discussed about reinforcement learning. There's another type of system or algorithm that enables machines to learn, and it's called supervised learning. Do you have questions so far? I mean, is there any question, comment? Yeah?
As a response, if somebody kicks it, does it somehow ever turn around and kick back?
That's a great question. So does the robot ever respond to humans? What do you think? No.
It has to learn to do that.
It has to learn to do that. So there was an interesting example from Microsoft. And they developed a chatbot called, well, I don't remember. But the chatbot from Microsoft was on Twitter, and it's still there. You can search Microsoft Twitter chatbot, and what you will get is an account that was able to respond to humans and was designed to greet humans and talk with them using artificial intelligence. At some point, people from Twitter started insulting the chatbot, writing racist comments, and tweeting the chatbot with hatred sentences. And after some time, the chatbot decided to respond in the same way. So it was shut down by Microsoft because it learned the behavior from Twitter users and learned to respond back. So we have great power with artificial intelligence, but again, great responsibility in how we train the system. So the robot itself doesn't gain any point for hitting the human back. And the robot is not thinking about that because its learning is focused on, keep walking and keeping the balance. That's the purpose of the robot. But if the robot was designed to respond back, then maybe they would.
Do robots, either the Roomba or the package order filling thing at the warehouse, do they use an absolute positioning system like global, like GPS, or are they just keeping dead reckoning, keeping track of where they've been?
So the Roomba uses the optical encoder, and the optical encoder is on board, which means that they get...
Remember different where it's been?
Yes, it memorizes the relative position. And one way to know that is because you can see that the paths sometimes are not straight, and that's because it's losing the orientation. It's drifting from the straight path. But that's based on a relative positioning system. I believe this one has that as well, although it could be added with GPS positioning or more information. And this is actually a very good question. Now, the nice thing about the robot there, and I have one more movie about that, is the more sensors we equip the robot with, the more they will be able to learn and to cope with the different environments they're in. As humans, they get information from sensory channels, and they use that information for their goal. If we are blindfolded, we'll be using our senses more, and we'll try to navigate the system using what we get. And in fact, I have this video here that shows you the type of information that the robot uses to navigate an environment. So this is the same spot robot that we've seen in the previous footage. But now at some point there, you will see an image here showing what the robot sees and how they are able to capture the world and process information. Should be just about now. There you go. So it has some information collected previously from sensors that are continuously scanning objects around, and it's collecting new information that overlaps with the previous information so that the updated information gives, obstacle position and gives a better representation of the environment. But that's all they see, and that's all they use to navigate in a system. Of course, if they had a global positioning system, they would use that. And this is what they're painting. Machine learning generated paintings based on the styles learned by software. Who's interested in that? Well, this painting here is called the Bon de Bellamy, and it was sold in New York for $432,000. So if any of you want to start a business, that's a good time. Come talk to me, I'll be happy to support it. This is a project by Google that generates music based on Bach's style. So they train the machine learning system with Bach's compositions, and then you can write some music and the system would harmonize it in a way that resembles Bach. And of course, Bach is just an example. You can do the same thing with your favorite artist. Country music, I don't know what you listen to, but that can be done. Now let's go a little bit to the scary part. There's an AI, which is called OpenAI. It's funded by Elon Musk and it was supported by Google. And this is what happens when you feed the AI with just a sentence about Brexit. So they trained the model with sentences taken from news, and then they can write one sentence, and then feed it into the network, and then the network is thinking and generating content. And paragraphs and paragraphs and paragraphs, and it goes on, and it can generate fake news for you. Do you have questions so far? I have 5 more minutes for probably, and then they will take me down with a shotgun. So this is a good time for questions that you have so far, and then I'll rush into the final piece, which is going to be about job and final remarks. Yeah.
I guess on AI creating content or anything like deepfakes and stuff. Is there any AI to counteract that?
That's a great question. And many people are thinking, okay, AI is able to generate content and to create fake images. So AI will be able to recognize me when I walk on the street, I'm captured by a camera, and AI is going to be able to classify me as Nicholas, right? Can I prevent that? It turns out that it can be done. And in fact, that's the #1 threat to self-driving cars. People have tried to create road signs that look okay to a human, and they resemble a typical stop sign or another road sign, but they contain features that trick the AI into thinking that that road sign doesn't exist. How is it possible? It's a little bit hard to explain, but I'll try to do it. So if I'm not able to do that, then I'll be happy to follow up, but bear with me on this. So the generator starts with noise. This is, just random information. There's actually no information there. And then they keep improving the network and training the network with real faces until they get to a generated face that is recognized as a human face, right? We can take a human face and implement some noise there, and implement a level of noise that it's not detectable by a human eye, but still tricks the computer system. And that's the way to counteract that, by increasing the level of noise so that it looks perfectly human to us, or it looks like a perfect sign, road sign, but it contains so much noise that a computer would see it as a turtle or as a shotgun, and there are videos on the internet, I wanted to include that, and I should have, that show exactly this process. So it's possible to trick, to play tricks on the AI, but it's very hard. And it's going to be harder and harder given the fact that the AI is evolving. I have some more examples. The last one is from Estonia, a tiny little country in Europe. They're trying to get rid of judges. Well, actually, they're trying to speed up the process of very simple legal actions by using AI and previous cases to decide upon, again, civil disputes, and they're the first country implementing that as a country. So this is a system instead that is able to listen to your phone and identify when you tap on your phone and recognize where you are tapping based on the microphone so that people can detect your password. And the machine learning system is able to understand when you're typing a password and when you're chatting with your friend. So the real problem with the future of humanity is one. The fact that AI is able to process information at a really unprecedented rate. So for years we said we have a ton of information, but we don't have the tools for processing that data, right? Nowadays we have. And the problem is that all the data that we share, all the information that companies know about us, can be used to train AIs in order to replace us. In fact, one of the main investors in AI is Uber. Why Uber? They're collecting data from their drivers with the app. They're learning how to drive a car to eventually get rid of all the people who are now self-entrepreneurs and make out a living with driving a car. So Uber drivers are helping Ubers to replace them with machines. Which again leads to the final question, which is, how do we, cope with AI? Well, we try to beat the AI by being smarter. And this is why there are so many different propositions on how to design a future in which AI will take over some jobs. Is there going to be a robot tax? I don't think so. Probably we'll be trained to become better designers for computer systems. We'll have to train to be better at our jobs, and whenever it involves empathy, to improve on that, because machines will never be able to deliver the same kind of care or the same kind of human touch. All the examples that I've talked about are classified as narrow AI, which means that each of them solves a very specific and individual problem. The future, and that's probably where singularity is going to happen, is going to involve a general AI consisting of an ensemble of all these systems, reasoning and thinking all together and exchanging information and circulating that information, so that we'll have this super brain thinking and using all the simple systems that we've seen. So that a system will be able to train the robot to, fight back or probably take over. The last thing that I want to mention before opening it to some more questions, hopefully, is the fact that we are calling it artificial intelligence, and that's a good term given that it's machines and software, but really we should think of it about a layer on top of our brain. This is the most evolved technology that humans came up with. Not only because it's able to kind of replicate some behavior, but it's able to beat humans in designing systems that are better than systems that we could ever come up with, because of the speed of calculation, because of the amount of information they can deal with. So we should think of that as an augmented intelligence that we design, and given all the responsibility that we have, but we should start thinking about how to use that as a layer that we can manipulate and direct accordingly. I'm happy to open it to questions. I don't want to be, shot or... So thank you for listening.